Hey everybody, this is Mr. Longo here, and we are going to talk about probability of the complement and geometric probability. So basically, complements are two different probabilities that will add up to 1. So for example, the probability of flipping a coin and landing on a head is 0.5. The probability of getting a tail is 0.5. 0.5 plus 0.5 is 1. The probability of rolling a 2 on a die is 1/6. The probability of not rolling a 2 would be 1, 3, 4, 5, and 6. So that would be 5 out of 6, and 1/6 plus 5/6 is 1. So that's what complements are. So the notation is the probability of A plus the probability of the complement of A is equal to 1. I've also seen notation where you have a bar over A, and that's also considered a complement. And I've also seen probability of not A, which means everything except A. So there's different types of notations for, complement use, just so you are aware of that. So what we're going to do is talk about some dice. And one of the things is when you roll two different die, you have to remember that you have 6 sides per die. So you have 36 combinations of outcomes. And here's a little table that represents that. And you can see that they kind of go diagonally this way. So this is the only way you can roll a 2. And then you have a 1 and a 2 or a 2 or a 1. So those are the only ways you can do 3. And then this row would be for 4s. Okay, going that way. So, what we have to do now is talk about complements to show you how they are useful. So, again, here's the chart. What's the probability that the sum is not 10? So that would be the probability of the complement of 10 is going to be equal to 1 minus the probability of 10. So you actually probably do this without even thinking about it. But the probability of not 10 is equal to 1 minus the probability of 10. Well, there are only 1, 2, 3 ways to roll a 10. So the probability of 10 is 3 out of 36, which we know is 1/12. So all we have to do is 1 minus 1/12, and we will find that the probability of not rolling a 10 is actually 11 out of 12, which is 0.917 or 91.7%. So again, probability can be written in different ways. Obviously, follow the directions on any quiz or test on how you're supposed to write your probability. Just know that they are all the same. So that is complements. So here's another one. What is the probability that the sum is greater than or equal to 5? So there's a lot more that are greater than or equal to 5, but the probability of greater than or equal to 5 is going to be equal to 1 minus the probability of all that are less than 5. So that's equal to 1 minus, now let's go look at the different ways we could roll a 5 or less than 5. And we have our 2s, we have our 3s, and we have our 4s. There are only 6 ways out of 36 to roll something less than 5. So again, you probably are already saying that in your head. It's like, well, that's just going to be 30 out of 36, which you're right. But I just want you to see how you're coming up with those numbers. So again, we said 6 out of 36 ways. And of course, that would reduce to 1/6. So 1 minus 1/6 would give us 5/6, which is equal to 0.833, also known as 83.3%. Okay? So that's complements. That's what complements are. So here are a couple more practice examples for you. Why don't you pause the video, give those 3 a shot. As soon as you're ready, click play, and we'll go. So the probability of the complement of A is going to be equal to 1 minus the probability of A. So 1 minus 0.45 is going to give you 0.55. So the probability of the complement of A is equal to 0.55. For number 2, you should have done the same thing, 1 minus 1/6. So the probability of the complement to A is equal to 5/6, because you just have to do 1 minus 1/6. And in the last example here, you had to do the probability that the sum is neither 4 nor 7. So the probability of not 4 or not 7 is going to be equal to 1 minus the probability of 4 minus the probability of 7. So for this guy, you can have 1 minus the probability of a 4 would be 3 out of 36. And the probability of a 7 would be 6 out of 36. And after you subtract those, you have 29/36, which is also known as 0.806 or 80.6%. Okay, so there's an 80.6% chance that you will roll something that's not a 4 or a 7. Okay, so that's complements. So now we're going to move on to geometric probability. Now the thing about geometric probability is you have to remember how to find area of certain figures. This first example is going to show us circles and squares. So what's the probability that your dart hits the center circle of this dartboard? So we have a square around it that's 8 inches by 8 inches. And the center circle has a radius of 1. So you have to remember the area of a circle is equal to the radius squared pi. So the area of our circle is just 1 squared pi. So the area of the circle is equal to pi. The area of the square is base times height. So the area of the square on the outside is 8 times 8 is 64. So the area or the probability that you are going to hit the center circle, so the probability of hitting the center circle is equal to the area of the center circle divided by the total area of the board, which is 64. So pi over 64 would give us 0.049 or 4.9%. Okay? So that's it. You have to know how to work with area to do this. The next example is asking you if your dart is more likely to hit the circle or the empty space around the circle. So the first thing we should do is find the area of the big circle. So the circle is got a radius of 3. So the area of the circle is 3 squared pi, which is 9 pi. And that means the area of the outside is going to be equal to the full area of 64 minus 9 pi. Okay? So now we have to find the probability. So the probability of hitting the circle would be 9 pi divided by your total of 64. And that will give you 9 pi divided by 64 is 0.087. I'm sorry, 0.442. And the area of the outside would be 64 minus 9 pi divided by 64. And that would give you 0.558. So we have inside of the circle would be 0.442. Outside of the circle is 0.558. So you are more likely to hit the outside. Okay? So yeah, that's that on geometry. So we have one example for you. You throw a dart at this board, and your dart is likely to hit any point in the rectangle. So what's the probability that your dart hits the non-shaded area? So are there a couple ways to do this? You obviously need to know how to find the area of a rectangle. And then you have a choice. You could find the area of 4 congruent triangles, or you can find the area of a rhombus. Either way you want to do it, you'll be fine. So pause the video, give it a shot. Once you're ready, come on back. So the area of the rectangle is base times height, so it's 8 times 6, which is equal to 48 centimeters squared. And then you could have found the area of a triangle. If that's 6, then this is 3. If the top is 8, then that's 4. The area of a triangle is equal to half the base times height, which would give us 6 centimeters squared. You also could have done the inside, which is a rhombus. Rhombus is half diagonal 1 times diagonal 2. So the area of the rhombus is 1/2 of diagonal 1 times diagonal 2. And you end up with 24 centimeters squared. So here's the thing. You only needed to do the red or the purple. You did not have to do both of them. But you can if you want to. So the full board, this whole playing board, is 48. So the area of the white space, you'll find that by saying that this is 6, this is 6, 6, and 6, which means the area of the shaded region is 24. That means the white region is also 24 because we found the rhombus. So the area of the non-shaded over the total area, that would be 24 over 48, which is 0.5 or 50%, also known as 1/2. Okay? So that's it. That's geometric probability and complement probability. This is Longo, and I'm out. See you, bye.